Yo, wake up the wake up the it's go time. Digital Maths Academy in the
Hello intellectuals, I am Mr. Thakur and you are watching this video in Digital Maths Academy.
You want power, you want skills.
Success is not about where someone starts, it's about how they move forward. Today's topic is very important. That's function. Function means it's the second phase, second stage of the relation, right? So before moving forward, first of all, we have to understand what is meant by domain, what do you mean by codomain, range, image, preimage. So first of all, we can see here we have mapping diagram, and we can see some elements are the members of the set A, and some elements are the members of the set B. So the set of all the elements of the set A is known as domain, and that of set of all the elements of the set B known as codomain. So domain and codomain are set, not to forget that. What's the difference between the codomain and the range? You can see 4, 5, 6, 7 are the elements of the set B. So all the elements of the set B belong to the codomain, but range, to be a range, the element must have the preimage, right? Very soon I'm going to explain what I mean by the preimage. So you can see 7 doesn't have any preimage in the set A, or 7 is not associated with any element of the set A. So we cannot write 7 in the set of range, right? So range means the set of the images, yes. So domain, codomain and range are the set, not to forget that. After that, when we see clearly, then we can write the relation like this also. R1 equals to 4 means what? Image of 1 is 4, R2 equals to 5, image of 2 is 5, and R3 equals to 6, that's image of 3 is 6. Likewise, we can say that 4 is image of 1, then you can say that 1 is preimage of 4. Similarly, 5 is image of 2, then 2 is image of 5. Likewise, 6 is image of 3, then 3 is preimage of 6. And after that, what kind of relations are said to be function, isn't it? So I'm going to highlight on this very important topic. So you can see we have so many relations, right? We have mapping diagrams. So there are some differences between the relations that we can see on the board, right? So in the first mapping diagram, we can see here the codomain, right, and the range both are equal, isn't it? Here you can see that the codomain and the range are not equal. Codomain means A, B, C, D, and the range means A, B, C only, right? So similarly that you can see so many mapping diagrams, but all these relations are not functions. So what kind of relations should be a function, I'm going to explain right now. So the first of all, you have to see carefully whether all the elements of the set A has image in the set B or not. First point, all the elements of the set A must have image in the set B, the first. And the next one is that preimage should not be repeated, isn't it? Preimage should not be repeated. Preimage means the elements of the set A, now which has image in the set B. So we have to focus on these 2 points, right? I'm going to show you some examples here, right? You can see that. So to be a function, every element of the set A must have image in the set B, and preimage should not be repeated. According to the first statement, every element of the set A must have image in the set B. So according to the first statement, we can say here, yes, it's a function. Yes, we can say, yes, it is a function. Have a look here. Yes, it is a function. Why? Because all the elements of the set A has image in the set B. This is also a function. Yes, you can say that. Correct? Because 1 is related to A, 2 is related to B, 3 is related to C. Yes? But when we see the relation 3, then it's not a function. Can you say why it's not a function? Because 4 doesn't have any image in the set B, right? So it's not a function according to the first condition. Every element of the set A must have image in the set B, and preimage should not be repeated. Right? So I have already explained what you mean by the preimage and image. So when you see carefully the relation 4, then you can see here 1 comma a, yes, we can write here 1 comma a, right, 2 comma b and 3 comma b. It's the relation, right, R4. Have a look here, b and b, that's image. Image is repeated, so when the image is repeated, doesn't matter, it's a function. Pre-image should not be repeated. So, and all the elements have image in the set B, so yes, it's also a function, right? But when we see the relation number 5, then have a look here, 1 comma a, 2 comma b and 2 comma c, right? That is R5. So have a look here, 2 is repeated, yes, 2 comma b, 2 comma c, and 2 is pre-image. So both the elements, that is b and c, have same pre-image in the set A, so it's not a function. Understanding? So we have to focus on these 2 points. All the elements of the set A must have image in the set B, and the pre-image should not be repeated, so we can say that 5 is not a function. Now we are going to define function accordingly. Definition of function, it's a relation from the set A to the set B such that every element of the set A must have image in the set B, and 2 or more than 2 elements of the set B should not have same pre-image in the set B. So this is the definition of the function, and we can represent the function like this, function from A to B, or in the set builder form, function that is x comma y, it represents the set of order pair, right, and x belongs to A and y belongs to B. Moving forward, we can see that vertical line test of a function. When we have a graph of a function, then you can easily find out whether it's a function or not by a vertical line. So how? Listen carefully. When a vertical line cuts the graph of a function at one point, it's a function, and when it cuts at 2 or more than 2 points, it's not a function, right? So I'm going to give you some examples, right? So when the vertical line, yes, no need to explain about the vertical line on the horizontal line, I'm talking about the vertical line, right? So when a vertical line cuts a graph of a function at one point, it's a function, but more than 1 point, 2 or more than 2 points, it's not a function. Have a look here, I'm just going to show you some example. So you can see some graphs, right? And these graphs are of functions, isn't it? So in the first figure, you can see that we have a straight line here, and whether it is a function or not, how to find out? So we can draw a graph, we can draw a vertical line anywhere, right? Anywhere we can draw. So we can see that here, the vertical line is cutting the graph at only 1 point, so it's a function, right? We can draw anywhere, yes, at only 1 point. So it's, yes, it's a function, correct? When you move to the second graph, then you can draw vertical line anywhere, right? So it's a function. Sure, you can say it's a function. Why? Because it's a cutting only 1 point, okay, at only 1 point, so it's also a function. So you can write here, yes, it is a function. Regarding this C number, okay, have a look here. We have vertical line already here. So when you draw a vertical line over this, right, so you can see that the vertical line cuts the given vertical line at so many points, a number of points, a million and billions of points, okay? So it's not a function. At least 2 or more than 2 points, yes, we get, the point of intersection, then that's not a function, so we can say it's not a function. Likewise, is it a function? When you draw a vertical line, right? So we can see the vertical line cuts the given graph at 2 points, it's also not a function, so we can write here, it's not a function, right? Likewise, when you see carefully, is it a function? No. Check. 2 points, right? It's not a function. Is it a function? Yes, here, when you draw, then you can see, yes, the vertical line cuts at 2 points, so it's also not a function. Have a look. This graph, when you draw a vertical line anywhere, it cuts only 1 point. Okay, so yes, it's a function, right? This graph, when you draw vertical line anywhere, if you draw, it cuts at only 1 point, so yes, it's a function, right? Some more examples, have a look. Is it a function? Yes. Yes, it's a function. Only 1 point. Is it a function? Have a look. No, it's not a function. Is it a function? Have a look here. Yes, it's a function, right? At only 1 point. Okay. So is it a function? See that carefully here. It is a function. It's for you. Okay. So if you know whether it is a function or not, number here is a L. So write down in the comment box if you have understood whether it is a function or not. Let's say I'm going to see the comment. Okay, how it is. Now next one also we have here. Is it a function? 1 point. Write down in the comment box. Okay. It's a function. It's for you. Okay, so 3 questions I have given you and you have to find out whether they are functions or not. If you think they are functions, then yes, you can write the numbers. Okay, L, M, N, yes, it's a function. L is function, M is function, or it's not a function. Please write down in the comment box. I of course appreciate. The next one is that inverse of a function, right? What do you mean by the inverse of a function? Right, so all of you know that in a function there are the domain and the range. Correct? So when the domain and the range of any function are interchanged, then the new function is called the inverse function of the previous function, right? I'm just going to give one example. So let me have here A and B. Here we have 1, 2, 3, and then we have here A, B, and C, right? And it is a function, of course. And A is related to 1 is related to A, 2 is mapped to B, and that of 3 is mapped to C. So it's a function, right? So we can write here F is a function, right? A to B. Correct? But when you interchange the domain and the range, what do you get? So here, when you interchange, this becomes B, and here it becomes A, right? And here becomes A, B, and C, and here becomes 1, 2, and 3, right? And this is a function, inverse function. Okay, and there's A is mapped to 1, B is mapped to 2, and C is mapped to 3. So this is called inverse of the given function, and we represent the inverse of the function like this. Inverse, right? That's the power 1. We have to write here. Little bit. Okay, equals to, or it is a B from B to A. So inverse of a function is from B to A if the function is A to B then. So moving forward, I'm going to explain about what do you mean by the onto functions and into functions. These 2 functions are very, very important. I'm going to give you an example. 2 examples I'm going to give you, then it will be more clear, right? So let me have here A and B. 1, 2, 3. A, B, C. It's a function 1. A is mapped to 1 is mapped to A, 2 is mapped to B, and 3 is mapped to C, right? This is the first. Second one is here. That's A, and here is B. So here is 1, 2, 3, and here is a A, B, and C, and again one more we have in the set B. That's a D, and here 1 is mapped to A, 2 is mapped to B, and that of 3 is to C, and it is a function 2, right? We can see, yes, there is a difference between these 2 functions, right? What's the difference? Here you can see all the elements of the set B has one preimage in the set A, right? But here the element D doesn't have any preimage in the set A, right? So we can say that here this is your onto function and this is your into function, right? Onto and into. Yes or no? Onto and into. So we can define it like this also. We can see here codomain. Here is codomain. Codomain is A, B, C, and the range is A, B, and C, right? So codomain and the range both are equal, right? So if the codomain and the range both are equal, such type of function is called onto function. In the onto function, you can understand it by another way also. All the elements of the set B has preimage in the set B. Likewise, when we see this function, then here codomain, we can see that here codomain. Its codomain is A, B, C, and D, and that of range is A, B, and C only, right? Because D doesn't have any preimage in the set A. So such type of function is called into function, right? So we can define it like this. If one or more than two elements of the set B do not have preimage in the set A, such type of function is called into function. And if all the elements of the set B, right, has preimage in the set A, such type of functions are called onto function, right? So I think I have explained all about all the functions, onto function, into function very clearly. So in the next video I am going to explain about the types of the functions very clearly. So if you really like this video, then not to forget to like, not to forget to share this video to your friends, to your surrounding. And if you are new in this channel, then not to forget to subscribe this channel, because it's your channel. So, and not to forget to click the bell icon to get the next video, another videos on time. So have a good time. Thank you. God bless you.
Digital Maths Academy in the house. SK Sir on the lead. Let's ride.